All right, section 5.2 deals with properties of exponents and radicals. A lot of these, so every one of these properties that's up here in this box, you have gone over in Algebra 1. In Algebra 2, though, we take it to the next level. So when I look at this first one right here, it's going to be a product of powers that we got going on. Okay, so you have two powers here, base exponent times base exponent. And the key here is that when the bases are the same, okay, so up top they have A and A. Here I got 81 and 81. What we can go ahead and do is when the bases are the same and it's a multiplication problem, you can take your exponents and add them. I'm actually going to switch out to red. Okay, so you got 81 to the 5 6 plus negative 1/3 power. And then from there, it's all about your skills with fractions. So we know when we add fractions, you need to have common denominators. So my common denominator is going to be a 6, which gives me 5 6 plus a negative 2 6. You go ahead and do the addition. 5 6 and a negative 2 6 are going to give me 3 6, which is the same as a half. And then using your skills from the other day, we know when we have a 1/2 power, that's the same as a square root. So the square root of 81 is going to give us 9. Okay. For this, they didn't really ask for all real roots, so I'm going to leave it 9. If you went ahead and did plus or minus though on that, you'd be totally fine. Okay. Remember, like when in doubt, when you use an even root, got to make sure that we have the plus or minus there. Okay, so that's A. It's an easier one. B, we got something a little more complicated. So when we look at B, we got multiple things going on here. We have a bunch going on inside parentheses, and this is all raised to an exponent. So this is really a power of a product that's going on here. When you have the parentheses, that exponent gets multiplied to everything. Okay, so my exponent outside the parentheses was 2/3. So on the inside, when we multiply that in, we're going to get x to the 2/3. 3 times 2/3 is going to give me 6/3, so I get y to the 6/3. And then in the denominator, 1/2 times 2/3 is going to give me 2 6. Okay, so that's step 1, getting it multiplied in. Your step 2 would be to try and simplify these. Okay, so we got a couple things going on here. When you have division going on, we have a quotient of powers. So we're going to find our bases that are the same. So in this case, my x's. And then division tells us to subtract the exponents. So I'm going to have 2/3 minus 2 6. And then on that y, we can go ahead and simplify 6 divided by 3 to be y squared. Okay. From here, much like the first one we did, it's all about your fraction skills now. So common denominator would be 6 again. You're going to have x to the, what's it going to be, 4 6 minus 2 6 y squared. Go ahead and subtract that. You got x to the 2 6 y squared. And then 2 6 we can totally simplify to be a third. So y to the 1/3. Or sorry, x to the 1/3 y squared would be our answer for that one. All right, so that's example 1. Example 2, this is like just problem solving, really. They want you to rewrite it, the expression using properties of exponents. So we want to go through simplify, when possible, just make it one radical that's going on here. Okay, so for my first one, I got the cube root of x times the square root of x. We don't want to have the two separate radicals there. So my first step here is going to be to rewrite it with fractional exponents. Remember, the root goes in the denominator, so I got x to the 1/3 times square root is the second root, so x to the 1/2. Okay, from there you have a product of powers. Okay, you got multiplication going on. When you have multiplication, we know that we have to add those exponents. So this is going to turn into x to the 1/3 plus 1/2. And then just like we did on the first example, common denominators for the fraction. So in this case, it's going to be 6. I got x to the 2 6 plus 3 6, which is going to give me x to the 5 6th power. And then realize if they asked you, you could rewrite this in radical form as the 6th root of x raised to the 5 power. Okay, so we got that one right there. And then B is the one that like trips everyone up, and like this is actually like a pretty important problem here. Okay, so you got the cube root of 16 times x to the 5. So as we did the other day, I like to break this up into 2 separate problems. So I got the cube root of 16, cube root of x to the 5. And then much like we did with square roots, you want to pull out any perfect cube roots. All right, so we're trying to find factors of 16 that are perfect cubes. So what like could I multiply, or what's a factor of 16 that we can take the cube root of? Turns out that 8 is a number we can take the cube root of. So I got the cube root of 8 times the cube root of 2. Okay, 8 times 2 is 16, so it works out. And then from here, you just have to do the math. So the cube root of 8 is 2. Okay, 2 times 2 times 2 is 8. And then we got the cube root of 2 times, in this one over here, I'm going to go ahead and make it a fraction. So I have x to the 5/3, x to the 5/3 power. Okay, when you have an improper fraction like that, we want to pull out all of the perfect x's that we can. Okay, so in this case, I can pull out one full x. Okay, x to the 5/3 is the same as x to the 3/3 times x to the 2/3. Okay, 3/3, 2/3 give me the 5/3. So I can pull out one full x out front, and then we're left with an x to the 2/3 over. So when we finish this up, we're going to put all our nice numbers out front in letters. So I have 2x out front. And then we're going to be left with the cube root of, so these are both cube roots, 2x squared. That is that is by far the most difficult problem you will run into in this 5-2.